Welcome to all of you. In this session, we are going to understand the Scilab program on circular convolution in frequency domain. So first we are going to have a detailed procedure of calculation of circular convolution in frequency domain, and then we will have the Scilab program for it. So we are going to have a view on the frequency domain approach for circular convolution. Let us first go through the various steps involved in that. So first step, calculate the output sequence length capital letter N. Apply endpoint DFT to the first input sequence, that is x of n, so that we can get x of k. Then apply endpoint DFT to h of n, the second sequence, so that we can get h of k. Then multiply the sequence x of k and h of k to get y of k. So this is for the realization. Then apply endpoint inverse DFT to y of k so that we can get y of n. And this y of n is the circularly convolved sequence of x of n and h of n. Let us go through a simple example of circular convolution in frequency domain. The two sequences x of n and h of n are given by x of n is equal to 2, 1, 2, 1, h of n is equal to 1, 2, 3, 4. Find output sequence y of n, which is equal to circular convolution of two sequences. Now getting into the solution, we are just noting down the first given sequences and the length of each of these two sequences. Now as per the step, calculate the output sequence n, that is given by n is equal to maximum of the given input sequences. So in this case, both the sequences are having the length 4, therefore the output is also 4. That means the capital letter N will have the length 4. The second step, apply endpoint DFT to x of n to obtain x of k. So this is what the formula, and the length is 4. We are following the matrix method over here. So twiddle factor representation, the input sequence, by multiplying that we are going to get the x of k 6020. Next step, apply endpoint DFT to h of n to obtain h of k. Again 4-point DFT calculation, matrix method. By applying that we are going to get 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Next step, multiply x of k and h of k to obtain y of k. So the two sequences are being multiplied. This is a dot product basically. That means the location wise we are going to make the multiplication. By that we are going to have the result y of k is equal to 60, 0, minus 4 and 0. The last step, apply endpoint IDFT to y of k to obtain y of n. So we are applying the inverse transform over here to y of k, and finally we are obtaining the result y of n is equal to 14, 16, 14, 16. And remember, in all the sequences we are going to have first element itself as the origin, including the input as well as the output. So in the Scilab program, first we are going to read the input values. One is the x and one more is the value h. So then after we are going to calculate the length of individual sequences, that is n1 is equal to length of x and n2 is the length of h. Then as per the procedure we need to identify the maximum length of the given two sequences, and that is being done in this line. Right? So then after, if both the sequence length are same, then no problem, we can just proceed with that. If not, then we need to make up the length of the sequences to the same length by putting the zeros at the end of the sequence, and that will be done in this line. Right? So if the sequence length x is less than the length of the n, then we are going to use this representation so that we can make it equal to n. Similarly, it is done for h. The reason is, for the further computation, the length of the x as well as the length of the h must require to be the same. Therefore, we are going to adopt these two lines so that we can make both the sequence length the same. Then after, we are going to apply the DFT to the first sequence, that is X, to obtain Xk, and then we are going to apply the DFT or FFT to the sequence H in order to obtain Hk. So then after we need to multiply both the sequences so that we can get Yk. Now apply inverse transform to the Yk so that we can obtain the Y, where this Y is going to be the circularly convolved sequence of X and H. So in between the values are displayed, and here the plot that is for the input X, and here for the input H, then here for the output Y we are going to have. And with respect to X and H, the plot will be after zero padding. What values we are going to get, for that we are going to have the graph over here. Now let us execute this one. So it is going to ask for the input sequence. Let us take 2, 1, 2, 1. That's the first sequence. The second sequence 1, 2, 3, 4. And here is the graph for this one. So this is the input sequence X, input sequence H, and this is going to be the output sequence values. So output sequence is present here 14, 16, 14, 16, and that's what we can find on this graph. And try to identify the x-axis is not starting from 0, instead it is starting from 14. Therefore the value 14 we cannot find any vertical line over here, instead it is there within this location itself, right? The values what we can identify here, so these two are the given values again displayed over here. So this is, if zero padding is there, then that is what the differentiation we can identify. Since both the sequence length are equal to 4 here, we are not getting any difference over here in this case. Then DFT of X is 6020. Similarly DFT of H we are going to obtain. Then multiply those two sequences, we are going to get Yk, and apply the IDFT for this one. This is what the value we are going to get, and this is going to be the circularly convolved sequence of the given two sequences. Thanks for watching.